Well, first, I would like to thank the organizers of this symposium. I was very glad when I was asked to give a talk. Following what Tony said, which reminds me, of course, lots of things of my collaboration with Cimo. I happened to meet Cimo whilst he was doing his PhD, and it was thanks to Tony. We started working together, and very quickly I appreciated also his qualities. Also his characteristics. I mean, it was somebody who didn't like to talk too much. He just went to the computer and worked. And for me, Cimo is the person who invented internet, because much before we were using internet, his communication was always by computer. Also, I was surprised when you showed this, Tony, when you showed this email, because I thought that it was only to me that he brought mails like that. So I'm glad to see that he was also doing that with all his collaborators. Then, of course, I got to know him better when he came to Marseille as a postdoc. And I must say, well, it was a period in Marseille which, for particle physics, it was very nice. There were quite a lot of people working on their PhD. There were several postdocs. Cimo was there, Josep Taron from Barcelona was there. And of course, they were getting together and having always great fun, which I participated from time to time. And one of the things I learned from Cimo, besides things in physics, is how to make paella. And I still have the recipe that he gave us to make paella, which I think, of course, about him every time. It's the only thing I know how to cook. And I learned it from him. Well, we worked together, and he's the one who worked together with other people, with some of the people who were doing their PhD with me, in particular Christoph Bruno at that time. Hans and I had been working together already, and I think Hans was very clever to realize the qualities of Cimo, so when his postdoc in Marseille finished, he immediately took him to Copenhagen. Now, for me, that was very good because it gave me the opportunity also to continue to work with, since I was working with Hans, to go to Copenhagen and work with Cimo, and we worked together in one of the papers that Tony mentioned about the determination of quark masses. I have very nice recollections of my visits to Copenhagen. Of course, I was there as a bachelor, and so was Cimo, so we went out together quite a lot. I still remember one evening where we watched one of the finals of the Champions League, where he was a supporter of Barcelona like I am, and in that final Barcelona lost 4-0, so it was a terrible event for both of us. Then, okay, life went on. We didn't work together for quite a while. I happened to get to know him again, and to a very personal level later on, and for me there was a sort of phase transition in our relations, which happened at a meeting in Glasgow about the hadronic interactions, the light-by-light contribution from hadronic interaction. I'll talk about that a little bit. And it was a very tense meeting where there was a lot of discussions and so on. And I remember very distinctly one evening with Cimo where we went to an Indian restaurant and we started talking a lot, discussing a lot. And we realized that after all these different contributions, if we try to get together, we could try to understand and to produce a number which will be a little bit the recollection of what was known at the time. And that was the beginning of this collaboration with Arkady Weinstein, to which I must say that if Cimo had not been there, I would have never been able to get on with Arkady Weinstein to write a paper. He was the person who actually put the three of us together and got to this result. After Glasgow, I saw him again at the Montpellier conference. There I already knew from him that he was ill, and I was very surprised to see the activity that still he was deploying in this meeting. So I was really surprised. Again, we went out together several times. We watched the match between Portugal and Spain in that meeting. So I had very good recollections with him. And the last time I saw him was at the thesis of one of your students in Valencia about a year ago. And again, just to explain you, I mean, Chimo was also always somebody who told you very directly things, and I still have this memory. I was in Valencia. I took a taxi to go from the hotel to the university, and that taxi driver was a very peculiar man. He started telling me that he asked me what I did. I said I was a scientist working in Marseille. So he said, yes, but in Spain there are no scientists. They all go away and so on. So I said, come on, come on. So I gave him a long speech of the values of science in Spain, in particular in physics and biology and so on. So perhaps I convinced him, because half an hour later, Chimo comes, and his straightforward way of saying things is, hi, Eduardo. Looks at me and says, we took the same taxi driver. Instead, somebody else would have told you a long story. I took a taxi driver who told me, no, we took the same taxi driver. Okay, now, every time I knew I was going to meet Chimo, I thought, okay, I'm going to tell him about this. I always enjoy telling him the last things I had been doing, or the last ideas I had, because as Tony said, he was one of these people who listen very carefully and who will give you some ideas, and perhaps a collaboration will come in. So I can't help it. I have to tell you the last few things I've been thinking as if Chimo was there. Now, it's true that Chimo worked on many subjects, but I think that the subject where he really worked harder has to do with two basic questions in particle physics, which is how does this QCD Lagrangian fix the couplings of the effective theory which takes place because of a spontaneous broken chiral SU3 symmetry? That's to say, when you integrate degrees of freedom, you end up with a Lagrangian which only has the Goldstone mode, the pion scales, and so on. And we don't know how to determine the couplings of this Lagrangian from first principles. This is what lattice gauge theories are trying to do. But of course, it would be nice to have some analytic approach to that. And he was very involved with that, especially with the second question, which is what is effective chiral Lagrangian, but in the sector of the electroweak interactions of hadrons. And that's where he did a lot of work, in particular with Hans, which he will tell you about. Now, as I said, I would like to tell you the questions that I would like to ask Chimo. Chimo started working on the constituent chiral quark model with Tony and with me, with variations of this model, actually. And I think he will be very surprised if I came now and tell Chimo, I want to tell you something about the constituent chiral quark model. He said, come on, this is old-fashioned. And he's right. It is old-fashioned, but I became interested in it recently because of the reasons I'll tell you. So I will give you some kind of overview on that. This constituent chiral quark model goes back to a paper by Manoir and Georgi, which in fact, what they tried there was to understand why is it that the simple model, the simple quark model, which is used for spectroscopy, was very successful, has always been very successful. And their question was how to reconcile this with QCD. Some people took that paper with interest, and certainly Tony was one of them, I was one of them, and that's Chimo got interested in that. Then little by little, we all have been doing different things, and I would like to tell you a little bit how the ideas have evolved from that. And afterwards, I will come back to this model. Essentially, it has to do with a paper. The reason why I came back to this model was a paper that Weinberg produced around Christmas last year, which I don't think anybody paid any notice, or very few. Now, one of the reasons why this model sort of got abandoned is that, in fact, it was realized later that it could be seen as a particular case of the Nambuyan-Alassino model, more specifically the extended Nambuyan-Alassino model, which is something that Chimo worked quite hard, especially when he went to Copenhagen with Hans. Now, in spite of these models, the difficulty has always been really to what extent those models are approximations of QCD. And the suspicion has always been that perhaps they have to do something with the limit of QCD, which is the large number of color limit. And I shall take that point of view. The large NC limit, the large number of colors limit of QCD, is a very interesting limit. I mean, there are many properties of QCD that in that limit are quite near to the hadronic properties that we see in physics. It is in particular the property that the spectrum of hadron states is, for each correlation function you can think of, is an infinite number of states, but narrow states. Width becomes 0 in that limit. Now, the question has always been, is there any relation or is there any approximation at which one could prove that these models I've been talking about are limits of large NC in some way or another? And that's a question which has fascinated some of us. Well, there is no direct answer to that, at least so far. But there is one statement which I think is interesting, which came in '98, which is that if you take this extended Namurian-Alassini model, which has constituent quarks, and one of the bad properties of the model is that it doesn't confine. So perhaps what we actually prove there is that if you take the pairs that do not confine in the spectral functions of the extended Namurian-Alassini model, and since you know explicitly the model, you can construct local operators which will absorb as successive approximations the terms that